Hey there, welcome back to the channel. We are back in it again. So, today we are just going to complete our entire implementation. We are not going to be focusing on speed, we are just going to focus on just completing our queue, adding different functionalities like try pop, try push, and something similar to Red Tops. So, let's go. Let's search into the machine. I use at the rate 192.168. It's just sitting beside me. Yeah. 279.139. Let's go. And yeah, yeah. So BFQ. But just look at this. I use R by the way. RCH by the way is my host name and user. I just thought it's good. It's okay. Windows. Yeah, well, that's just going to work on functionality today. No need to execute anything right now. So we have made push, pop, and place, and front. There are different types of push. So this one is just taking value, that it can take references or R value references, well, R value references with already understand, I guess. Okay, so yep. Um, let's look at what other functions does Rectops do have as. So Rectops SPSC will also eventually move to NPMC, like stage by stage, single producer, single consumer. But we'll do first SPSC and then NPSC, then NPMC maybe someday. I think I can really like add stuff, like I can show off a bit in NPMC, but never know. By the way, if you want to see like how is it performing right now, so make clean and just like well, it's already clean, so you don't have to run that. So it tops 30,000 operations per millisecond. Well, it's less because the machine is a bit shittier. Look at this 40,000 and 225 nanoseconds around about time latency. So that's cool. Okay, it's taking some time. Okay, let's see. So, why is my document not working? Does document not work on GitHub? Yeah, okay, okay, one second. Come on. Why is it taking so much time? Okay, yeah, that's fine. So we have void in place. So we already covered this. So SPC floating items of T with capacity this. So we already covered that. Then we go into PFQ storage. And look at this. Also, I think should I do it right now? Yeah, let's do it. So, so if I do git log, look at this. So this is my head, and this is the temp. I was pushing on temp earlier because look at this. So I need to use perf and some other thing that was present CPU set. It just tells you like what CPU like CPU numbers or something, so you can pin the CPU cores. There is nothing similar to that in for ARM architecture, I guess. So I had to use that, and for that I needed a way to transfer the code because it isn't GUI. It's just simple Arch TTY minimal. But then I install a GUI later, and also I figured out like maybe I can just use SSH. Yep, that was that wasn't obvious to me. So I'm just going to. I don't want these logs in my main branch because it just looks serious. So I would rather just you know copy the stuff. So if I do this, get status. Yeah, okay, it's the only thing. So if I do this, I just take everything from over here. Get just doing this. Then get checkout email. Get status. Yep, and then this was my earlier. Oh my god, that's it's so obvious. Okay, right, paste this. Git status, git diff shows a change. We can just do added a bunch of lines over there. Yep, cool. I can just do a git add, git commit dash and I can add like added include some stuff after something better. Uh, mm, what should I call it? Improved code. Git push. Yep. Otherwise, okay, it's connected, right? Okay, it worked. So, okay. So now I'll just be working on the main branch. You can just delete the 10th branch, I guess. Okay, I'll do it later. Let's focus on the key. So we have to write, what- what's it called? Appearance, I guess. Wait, what's this? Right. Okay. So dark mode is on, but I think this isn't after that. Is that the reason? No, it's off. Why isn't this not there? Light mode is off. I need to high construct for my dark mode or bold based on the access settings. I don't want to. Why is this? Why are you doing this? Oh, okay. Fine. Void in place. So we do have a void in place which takes a R value reference. So it's not necessarily an R value reference. It's just copying this. So for taking R value references, uh, do we need to say it over here? Like this takes an R value reference. So like if I do this, also people made of this stuff, hash include string, and then hash include just the file beside us, which name. So we'll create a copy of it. So pfq 8 and something of capacity 100. Then pfq dot in place 1. So this is supposed to be something. Then return 0. So equal g plus plus student and that's that. So new dot cp and then dot out. It worked. And if we go over here and add the R value reference sign, does this still work? And it does. So when we dot out, will it still compile? It does. So okay. So that's good. That's what we had to do. So if we go in the push, so we have this in place. We should also have this. So try to include an item using in place construction returns true on success if all its if queue is full. Okay, so that's chill. Okay, now that I remember, I should also write logic for um, relating it. So like I think so it's already present. There is a start and the end. Now I should add checks, like it shouldn't collapse, it shouldn't clash. So let's say if I'm trying to push and you check, so okay, call this. Join and place, right? So right, join place, non accept, join and place. So it will check if it's full or not. Blocks if queue is full. Blocks of queue is full, so there's a loop inside it. Okay, so I'll try and place. So I'll just take this stuff here. So wait, our initial value start at zero, both of them. Start is supposed to be the start, which is the tail, and the end is supposed to be where we push. I should really change those names, right? Start should be tail, and end should be head. Tail, head, tail, head, tail. End is the head. And end is supposed to be the head. Then he asks for front, which should return tail, replace head, replace tail, replace head, then replace tail. Cool. Hmm. I don't think I need the capacity logic right now, so capacity, I don't think I'm using it anywhere. Okay, I am. Mm, fine, let's work on it. So if tail and head are equal to are equal, well that's weird because they can be equal due to there be no element at all, or they can be equal when they are wrapped around it. So if both of them start at a I'm seeing so much horrible code here. BFQ next. Like this is horrible code. This is really horrible code. Head dot store. God, this is so horrible code. Now that I think of it. Wait, it should be like void push pt no accept. I'll take what should be the next element. Head dot load. So state memory order relaxed or something. I'll add the correct memory ordering later on. How about that? So head dot load, what is the current one where I should be pushing stuff, right? Hmm. This is capacity. I'm so sorry. So 17 minutes in. Okay, I have to work faster. So this, okay, so that's the good. I dot load capacity, and then right. So the next variable has what should be the next variable. So I do bfq dot bfq next is equal to student move d, right? And I'll do head dot store. So this should be the new head value. Head dot store. Why am I doing n dot load plus one? This doesn't make sense. I already have what should be the next value. Head dot store should have the next value. Why am I doing one more operation over there? Also, one more thing is that I can't really do this. I need to have a loop running that checks like, is it the value that we wanted, right? Mm, where it tries to push just a very order relaxed capacity. There's just something is wrong. Head dot store leg. Maybe we can add compare exchange rate, right? Okay. So what we add current head is equal to head dot load, right? Cool. And then we do this current head. So we have the next value using current head mod capacity, and then we do compare exchange week in the push. So compare exchange week has an expected value. If it's true, then if it's the same. Okay, if I compare, okay. So while compare exchange week, okay, let's do head dot. Also, it should be true. So while compare exchange week, so until it is expected value, which is our current head, until it is expected one, we'll replace it with next. Okay. So what will it do? So compare exchange weak is will return false if this is not the same, and if they are the same, it will just move out. So compare exchange weak if it's not equal to current head, that means someone has modified it, then it will skip it and replace whatever the content inside head was into the current head, and it will keep checking. Okay, so this seems logical, and this is not. I will just add this. So this makes sense to me, right? I'll just remove this for now and test something. So run make make clean make run. Okay, so Q dot entries I cannot bind unknown reference of type to any reference end I. Okay, that might be risky. Someone wants okay. So there are multiple indications. So for now I'll just keep sorry. For now I'll just keep in place as a normal T. Okay. Cannot be overloaded with this push. Void push DT no except what is happening. There is only one push, and okay, there is this push which we doesn't want. So let's try this. Exported this. So this. Okay, forgot that. Yeah, just don't do it. 13,389 and BFQ is going to be bad. Will it be looping on forever? Should I edge stop edge stop shows CPU capacity? Oh, the zero code is at 100% capacity. So I'll stop it. Okay, 0.7%. Just a minute. So okay, back at it again. So if I look at process, nothing's so something is happening. Maybe I don't have the complete understanding of uh, so maybe I don't have complete understanding of compare exchange week. So compare exchange week, I think this is what people do. So compare exchange week. So back at it again. So compare exchange week is atomic operation that compares the value of an atomic object with an expected value, and if they are equal, replaces it with the desired value. It may fail spuriously, meaning it can return false. And the values are equal, which can be useful. So uh, with an if it's true, so desired success, failure, or the other. So comparison of weeks, lesson used for that. So yeah. Now make new node the head. Now if the head is no longer what's stored in the new node next. Some other thread must have inserted a node just now. Then put that new head into new node next and try again. But should I do that for this? So this is a SPSC queue, right? In a SPSC queue, no one is going to modify head except at place and push. So I shouldn't be adding this compare exchange week at all. Right, right. I, I forgot. So, okay, in next, we have head dot load, where we are the relax, more capacity, we are the next, what it's supposed to be. And instead of this, we can just write head dot fetch add one and stood memory order release. Select this. So we clean with one stood memory. No, it's a mistake. Stood memory order release. Back at it again. Okay, so we have stood memory order release over here. So let's check, does it work now? SPCQ 13,000 operations per millisecond. So this should reduce our operations. Yep, it did. Uh, Wait, but why did it do that? We actually reduce the number of operations, right? Instead of a separate load and then store. Okay, the operations per millisecond have been reduced, but the latency is good. I don't understand why. So what we did is head push. We shouldn't be doing this. Instead, this should be next, right? Head dot store next plus one. Store memory order release. This should be the correct thing. Well, it's not going to change performance, I guess. 70,000 operations. I think it will be still be okay. It's back at it again. Maybe I should print something. So, okay, this logic seems correct. So, int next gives us what is the correct value that we should be storing at. Then we have DFQ. Well, this shouldn't be next. This should be no int next is where it is. So, DFQ next is stood move T. It stores it, and then head dot store next plus one. So head dot store. hmm, So head dot store is next plus one. So we store the next plus one. Okay, and then we let this one handle it. The next model handles it. Okay, okay. So this is correct. So void push is correct. Void pop is also correct. Fetch r plus one. That's just well, we shouldn't be doing fetch r plus one. There should be next in this logic too. So int next tail dot load mod capacity, and then the pop operation happens, and then we should be storing so tail dot store next plus one to memory order release. So this seems correct. 13,000, I think there will be a drop in the performance. There wasn't. Okay, cool. So code 1, and then suddenly there's code 2. Sorry, code 0 and code 2 act strangely. Hmm. Okay, so I have it stop running over here. Let me show it to you. So I can monitor what performance. what process is taking, doing what and all. Okay. Mhm. This mostly is just standard stuff. Okay. So we go over here again. So so this is fine. This is fine. So pop is working. And place is correct. Like it's just calling push instead move, like passing it by our value reference. I should have employees. Wait, why wasn't this working? Like the previous one? Why is even passing I to it? The benchmark of GPT to evaluate of type with cannot find unvalid reference of type int more int and element type with. But why would I even do that? So I'm doing this if benchmark and place. Yeah, someone is doing this. Yeah, and if anyone is doing in place, that's fine too. This should work. But why doesn't it? So I've already told like what it needs to do. Should they have used string move on their side, but they didn't? That L value cannot be converted to R value implicitly. That's what there is about. Cannot bind R value reference of type this to a value of type int. Yeah. Q2 dot in place with Q2 dot in place Q1 dot front the definition of they should have used to remove on their side, but I'm really not sure what this area is about. I'll look into it afterwards. But okay. So I guess most of this stuff is correct now. So I push this. I guess pop is correct. I will pick up. So pop is correct. We have front. So front, no one is going to modify this. So int tail dot load this. Int head dot load is this. So a lot of things can go wrong here in the front, like tail can be modified or head can be modified. And okay, and then we just return that pointer. Hmm. Okay, let's just start implementing stuff. So we have try in place, which will try to in place. I need to have a tail and head logic, right? So if both of them are in the same place, should I check how did they get there? Sorry. Try to empty an item using if this instruction returns true on success and false if Q is full. Q is full, it returns false. So Q is full, right? Try push is also something similar, but how to do that? Like, should I keep a counter that has like how many elements are present in the queue at this moment, and if it is equal, so like if head and tail both of them are equal and zero, well not zero, but so head and tail can be equal. head and tail can be equal in two states. One is when you just never added anything, like there was no element to push or pop, so they both stay at zero. And then another difference of them being at the same place is when we push equal number of stuff and pop equal number of stuff. So they again reach the same index. But then how should I find out like it's not like okay. Or the third case, like if there is never a pop operation and we just push it. So they both reach the same index again. How do we find that out? Earlier, we could have kept a counter, like head and tail can be simply just, but that's not feasible. How to do it? Let's look at some different functions to implement first. So in place is fine, push is fine. Point push. Okay, what is this? Into an item using move construction participates in overload resolution only if state is constructible. Block if queue is full. Blocks if queue is full. What does it mean when blocks is queue is full? If queue is full. Let's look at the original top implementation. Like what does it mean? Like I won't look at the code completely, but just need to share to run it from the different tab. So a normal push operation. Yeah. Okay. So push just does and place B this and place B just does it. Stood forward. So this is what they talk about. Like this, enable if is constructible in place. Yeah, okay, and this is doing the stuff. This takes it. So whatever. Yeah, yeah. So we load the right index. Right index. Auto consider right index dot load. Next index is plus one that. If next index is equal to capacity, then next right index is zero. And while uh, like next right index is equal to read index, and it's equal. Next right index, while it's equal to read index. Okay, so the current values start with uh, where are they declared? What are they? So read index. Read a bit cost. This, this, this. Straight atomic, both start at zero, read ID, maybe it's cache. Oh man. So my head is moving a bit. So, I did not check, like, how do you check? First of all, I'm really annoyed at this shit. I'm sorry to say. I'm going to go on Safari, just stop, go, stop, I'm going to do this. I can just do this. Yeah, okay, this should be in dark mode. If it's not, I'll be really angry. Okay, so it is. Okay, so we have this. We still consider in place. How does try push work for this logic? Try and place, yeah, of course. Right index is this, next right index is this, this, if this is equal, state of read IDX cache, else cache is used to reduce the amount of cache. Is used to reduce the amount of cache. And how does it reduce stuff? Let's see the first one, please. Next, right indexes. How is my how is my I'm not able to use any of the try ones. Yep. Try push, try pop, whether this is NQN item using loop construction, participates in overload resolution, and there is constructible blocks of keys. Okay. So void pop, size to size, yeah, definitely I can do that once the number of items available in the size, available in the queue. Okay. So once the number of items available in the queue. I should also add an entry. So when it's an entry, when they both are equal or something. Okay, okay. This will tell us some stuff. So empty right index of load is equal to read index of load. If it's equal, it's still empty. So try includes. I'm just trying to. I'm just going to. I'm going to replace it like this. So if I add a boolean empty, it should have a simple logic. So it will empty return it out. So yeah, so head dot load student memory order acquire is equal to tail dot load student memory order acquire is equal to return it. For the size, it is return. And what am I missing? This works. This works. This works. Okay. So eight size. So size should be let's not do this. So in size, so size is head minus. Oh, I need to change the logic such that it pushes the next one. Sure. Sorry. So it's a frame buffer. How should I do it? It's just so confusing. So like if I have both of them at the same index, we can't say like if it is full or if it is or if it is empty, right? So how about we do this? So whenever this happens, we try to push on the next element on the previous element. So maybe you can change how head and tail are portrayed, right? So our head is where stuff is being added. So this is the it's like which maybe I can use so excavator instead of dark mode. So let's say this is our cube. So this is let's say 1, 3, 2, 9, 5, 6. And this is This is our let me see. This is our head, right? This is the end. This is the head. This is kind of like a signal, and it's the tail, right? So tail points at what is like a position of the tail, and head points at like where the next element should be inserted. So maybe we can make the logic. And when the cue is in its initial stage, it's like both the head and the tail point at the same place. So there's if there's even one element present, the tail is pointing over here, head is pointing over here, but when it's popped, both head and tail point at the same location. And one head and tail will point at the same location again. So maybe we can do something like a head and tail both. Um, I don't know this way. I just can't think of like how should I design that unless it's paralysis. How should I make it so that the only reason when they are equal is when it's empty? Like why am I saying this is that let's say if I insert a value 7 over here, so if I insert 7, uh, this will point over here. When I insert 8 over here, probably when I insert 8 over here, the head will move again. When I insert 9 over here, head will move again and point over here. And when I move 10 over here, then the head will point to the tail's location. But we can't really tell if they are in the same place because of some reason or how should I design this? So we can add Like we head and tail initially we point at different locations and they point at the same location. Okay. Something that should also reduce our competition. So like not a lot of stuff. Like the new idea that came in my mind was maybe we can check what is present at that index, and if it is equal to null. So after every pop operation, we'll just uh, zero initialize, not initialize, but zero the entire memory address that that is present there. So if there is something non-zero, that means the array should be full. But that is still taking us some time, right? Actually do it. So so push, try and replace should be the thing. If it is equal, then return false. And if it's not, well then let's keep adding or whatever. Right index points to new right index and then return true. When is read index cache updated? So read index cache. So read about this. Index cache is load while increasing. I seriously don't understand this stuff. We can outline like how many elements have been started till this point of time. We can keep a counter to that. Elements inserted. Then let's try that. So we'll keep an elements inserted value. So int elements inserted to initialize with 0. For every pop, we'll do elements inserted plus plus. This should be an atomic variable. So align 64 string atomic int elements inserted. Maybe we can keep on the elements. So elements plus plus. By default to the sequential consistent which we don't want. So fetch add 1. Store the memory order lax because it's a simple counter, so we don't really care about it. Fetch add, and then this we can just add elements dot fetch sub memory order relaxed. Cool. push, empty should do the same thing, front shouldn't do anything, and then size should do elements inserted. Yeah, return elements, dot load, stood, memory, order, relaxed, right? And for empty, I'll check if elements dot load, if elements dot load. So empty will have the logic like if elements dot load, stored memory, memory order, relaxed. If elements are present, then we'll just so elements are present over here, right? If elements are present, then we return false, or we can just return true. So let's check 13,000 and earlier it was 49,000. So okay, there's our performance hit. Let's do it again. 13,000, 10,000. Latency is lower still. Oh, did not want to run that again. So okay. So because of this, what happened is that an extra relaxed operation is present, but it's relaxed. It shouldn't cost anything, right? Not sure what is happening there. Like something like counters are fine. Mm, It also saved us on two loads for empty and converted to a single load. Let's check what is taking so much time. Right? Okay. So what was the thing? Like, okay, we make clean, we make debug, module for debug. It's because unique file was updated, but I did not take unique file from there. So make check out 10 status, give diff. Uh, okay, so I'll just git stash it for now. Git checkout 10 and then make file. Git checkout name. Git status. And then git stash up. Then change our make file. Make clean. Make debug. rme.out, rme.cp, and we just do perf record debug pfq 6000. This might even get so pfq and then we do perf report. So what does the report say? Front is taking a lot of time, also push, and also pop. So front is taking most of the time, and that is because of this operation, which was already present, which is moving stuff. Sorry, yeah, it's fine. Why is push taking so much time right now? Because of exchange, XCHG. Exchange is for compare exchange in push. So wait, where do we have that line? So push, there's a exchange stuff. So elements dot fetch add. Is this what you're talking about? Definitely this is taking ahead, but I don't think there's another option that we have with us. If you do a normal plus plus with memory order used, then plus plus on atomics. Still memory order. The synchronization order and constraints imposed on with the suspicion terms is guaranteed below. Okay. So I think we need to reduce elements a lot of times because push and pop is happening a million times and this is causing it to be a bit difficult. How should I how should I do it? I did not think this through. There should be something better. And the next thing is so like push, pop, push, pop, push, pop. Maybe you can just keep increasing head and tail, and only when we are trying to store it into those, uh, only when we are trying to store something like a like in push, then we mod and find like where do we need to do it. Let's try that. I don't see any other option with us. So head and tail will be will just keep increasing. So int next does this, and elements dot we remove this. Head dot store head dot fetch add one. And in this case, remove this and then fetch add one. Next is okay. Uh, in front, we just check like if they are equal. Just move it forward. this, and if t mod, well, I can't convert it to t is equal to the h, right? So if t minus h, if t mod capacity tilde of this, mod capacity, mod capacity, yeah, okay, this stays the same. BFQT equal, and for size, we just return. We just need to calculate this again, and then yeah, not this space model capacity. We have T and H with us, and then we'll just do like T minus H mod capacity, right? So return uh, absolute value of T minus H mod capacity. Cmax. And for empty, we can just do, well, if something is empty, that means so push operations happens, pop operations happens. So we load this, and if t is equal to h, if they are equal, then return true, and return false. How about that? Make clean and make run. 16,000 operations and then 7,913 271. Okay, we gained our edge because we removed that horrible elements one. 9,000. We still need to pump those numbers a bit. Number of operations per millisecond is quite bad. So latency is calculated in like in benchmark.cdp or TTV. So duration of cost nanosecond stop and start. Okay. So what it does is that start and stop. So for I and iteration Q1 dot in place I, not Q2 dot front, Q2 dot pop. So it just tests in place. Okay. So in this one, this tests are in place. Hmm. Get it, get it. Okay. So B of Q dot H. So this is my logic so far. So now that I think about it, I think I understand like why do we need to keep a cache with us? Like we are checking the T and H so many times. Maybe we could have something instead of that. Like maybe an indication like if it was modified or not. An atomic flag, tail modified, head modified. If it's just taking size and empty, if it isn't modified, then we don't really. That's not going to increase our performance, but still. So we do this. Push pop and freeze are still the same things. Fine. So we have implemented empty and size. Returns pointer to front of queue does not pointer if queue is empty. Returns null pointer if queue is empty, right? Which it does. Yeah, equal, that means they are null. Template type name B, pool, try push. Okay, now I can implement like try push and every single thing. Like, okay, so void try push TT, no accept. So I'll do the same thing. Look at the memory address. Not not this, but I'll try to do this. So if empty, I to do this, right? So this dot empty. It's false. No, I need to check like if it's full, right? Shouldn't make a function for it that does it for me. It's like full, well, again, it does the same thing. So if t, if stood absolute value of t minus h is equal to capacity, that means it's filled. Return, it's filled, right? So return full. All else return false. If filled, return false. So if it's filled, if filled, if it's filled, then return false. That's it, right? If I push, yeah, try to enter an item using the instruction, returns true on success, and false if it is full, it is full. Participates in overload resolution from the if is accepted. 1.21. I don't understand what this is quite yet, so I'm going to test that. So just work on this. Also, one thing that we can do, which is the basic, is that convert this to your reference, right? So that should change some amount of things for us, not by a lot, but yeah, we, we gotta do what we gotta do. If it's filled, we just put on false that we try. If it's not, then then we try a push. Push, still here, very good. Mm, this should work, maybe. Okay, then we're going to a value const reference of type this to an R value of this. Remove reference type, okay, and okay, I will reference copy that to another reference. Yes, fine, no, whatever. Return statement is the value. If when the return false, I will just push the code 13,000, 9,000, or 8,000, 270, yeah, 261 nanosecond, around about time. Uh, just give me a minute. So it's been a long time. I haven't uploaded the video yet. I need to upload it, So I think we'll stop it over here, trying to optimize maybe something like that. So okay, we'll stop the video over here. Thanks for watching this video. I'm Aditya Bashani, and I am an engineer for fun. Bye.